All right. Okay, so we're still in Chapter 8, Section 1. Remember, I did email everyone the exams. I just emailed everyone the notes just now, so you should have it in your inbox. Okay. All right. Okay, so with that said, let's keep going. So remember, basically what we're looking at are systems of linear equations. Okay, wait, hold on. That's what we're looking at now. Okay. All right. So that's what we're looking at now. Now, if you remember, a system of linear equations. Basically, here we're looking at only two equations and two unknowns. X and y. What we're also looking, and also the exponents of the variables. They're 1, as you can see. I'm pretty confident you can look at when these equations are quadratic. A system of quadratic equations, you can consider that. I mean, off the top of my head, I don't know if the book does that, so we're not going to cover that. We're just going to focus on this. You actually could consider a system of 3 equations and 3 unknowns. And the methods that we saw so far, substitution, you can use that to actually solve such a system. I'm not going to go into that though. It does take more work. To graph it, you would have to be able to graph in 3 dimensions, and I definitely did not go over that. So let's keep going with this though. We did see substitution, but let's now consider graphing. Again, I did show how to graph things in Desmos, so we'll do a few examples of that. Since the class is online, I'm not going to have you sketch a graph by hand. And graphing, I'm not really going to emphasize too much. Graphing you can really use, at least in this class for now, the way things are, almost as like a check. If you're doing another method, substitution, or we'll see elimination today. If you think you have a solution, or if you think there are no solutions, you could graph the equations in Desmos, and you can really see for sure if you're right or not. Okay. All right, so here, for instance, if we graph these, let me just go through how to graph these again. So I'm going to have to share with Desmos. Let me do that. I'm not sure if there's a way to share more than 2 things at once through Blackboard. I mean, if there is a way, that's great. And I don't know how to do it though, but I'm not sure if there is a way to do that. But anyway, so we're in Desmos now. Let me graph those 2 equations. I did have the picture here, but let me just graph it. The equations are x plus y equals 4. Okay. The other one is x plus y equals 2. And you can see that these 2 lines never intersect. Remember, graphically, we want points of intersection, right? That's what a solution to a system is. It has to be a solution to each equation. Graphically, that's saying it has to be on both lines. Hence, the graphs have to pass through both points. Hence, you have to have a point of intersection. However, here, these graphs never intersect. There is no point, ordered pair that is, that's a solution to both of these equations. They never have any points of intersection, so there's no solution to this system, as you can see. Okay, I probably said it in many different ways, but the bottom line is there's no points of intersection, no solutions then. Okay. All right, so that's okay. Let's go back to the notes. I mean, the notes are in front of you. I did email it to you guys, to everyone, excuse me. So, all right, so the lines never intersect. So because of that, there are no solutions. Now, this one I was going to have everyone try, but I figured it might be better if we just do it together, since we're starting a new lecture today. So to do this together, again, we have to go back to Desmos. If you did graph it in Desmos, though, well, let me just show you what would happen. You would get something like this. But you would see there is a point of intersection. You would see, though, there is a point of intersection if you graphed it in Desmos, okay? And this is what you would get. just this point, which looks like it's 0, 2. So it looks like 0, 2 is a solution to both equations. X is 0, y is 2. Is that right? That should be 4. How is that a solution? All right. I think there's a mistake here. I think this should be a 2. That's why. There we go. My mistake. That should be a 2. I think I typed it in wrong. Sorry about that. Let me just quickly fix that. That should be 0, 2. Okay, good. My mistake. Okay. Right. Okay. So that's what we get here. So there's only one solution, and the solution is 0, 2. Okay, good. All right. Okay, so that's graphically. Let's now move on to another example. So this one here we're going to solve by substituting. Then we will check this by graphing, okay? Then we will check this by graphing. So again, we're going to check with Desmos. So for substitution, remember, the whole idea is you want to use an equation to get one variable in terms of another. I mean, basically, it boils down to eliminating a variable. That's what it really boils down to, and that's what we're going to do here. So from the first equation, as you can see, it's probably a good idea, as I have here, to get x in terms of y, which is what I'm doing. Now, why am I doing that? Well, notice that the coefficient of x here is a 1. So because of that, I mean, you theoretically could get y in terms of x, except you would then have to divide by 3, and then you would have fractions. So I think it's better to get x in terms of y from the first equation. So that's what I'm doing here. So what am I doing? Again, I'm adding 3y to both sides. We get x is -1 plus 3y. That's what we get. That's what I have here. Okay. Now, so what do you do next? You substitute, hence the name, substitution method, into the second equation. So you substitute into the second equation. That's what I'm doing down here. So we got x in terms of y. Well, let's use that. We have 2 times -1 plus 3y minus 3y. Now remember, you want to distribute, right? You know, order of operations. You handle multiplication first. Parentheses, excuse me, first. So we distribute, in other words, like so. We get -2. That's over here. Let me draw it with a pen. We get -2, or 2 times -1, and then 2 times 3y. That's where the -2 comes from, and the 6y comes from. So we have -2 plus 6 times y minus 3y, which is -2 plus 3y. So now we have this to deal with. And remember, the second equation, the left-hand side, is what we just worked with. Don't forget the right-hand side. This is 7. So we have -2 plus 3y is 7. This equation we have to solve. And this is easier, right? Because essentially now we only have one variable to work with. And that's what we're going to work with. Okay. Good. And that's what I do in this slide. Here, we're going to get y, figure out what number y is, okay? So again, we want to isolate it, right? So let's get the 2 out of there. We add 2 to each side, okay? We get 3y equals 9, right? But we don't want 3y, we want y. So we divide by 3, and we get y equals 3. Y equals 3. So from here, we know what y is, but what about x? We're not done, right? We need x. Well, we know, remember, that x is -1 plus 3y. I mean, you really could go back to either equation, replace y by 3 and get x, but we don't have to. We have this. We know what x is in terms of y. So let me say again what I just said. Since we know what y is, right, you could go back and replace y by 3 in either equation and get x, but you really don't have to because we know what x is in terms of y. And that's what I'm doing here. We know x is -1 plus 3y, which is -1 plus 3 times 3, which is -1 plus 9, which is 8. So our solution then is 8, 3. And as a check, sorry, let me just wait. I don't want to go too fast. As a check, I mean, you could just check the answer. Let's also graph it, and that's what I'm doing here. I'm going to graph it in Desmos now. Let me just, I got to share Desmos, so let me do that. Bear with me. Here it comes. There we go. Okay, so let me just graph this. We have x minus 3y. -1, I think it is. Yeah. And 2x minus 3y, 7. And it looks like, oh, we're right. This is the point 8,3. Notice if you hover over the point of intersection with the mouse like I'm doing, you can see the point. Or you can zoom in, right? I mean, if you click on anywhere in the plane, you can move the plane, and you could zoom in. See? We have 8, 3. Okay? Even though we're zoomed in, Desmos still shows the numbers on the y-axis here. So we have our point 8, 3, so we're right. That's good. Okay? So that's what we get here. Okay, good. So our answer is right. You know, that's a good way to check. All right, let me get back to the notes.